Welcome to our lesson on factorial notation. This is basically just some notation. It's no really new math. It's math that you learned when you were pretty young, but it's just a new way of writing something. So for any natural number, so what is a natural number? A natural number is basically 1, 2, 3, 4, all the counting numbers, so all the numbers you use to count. 1, 2, 3, 4, all the way up to till you can't go. And we will include 0 as a natural number here. Sometimes people don't, but mathematicians usually do. Then the notation n and then an exclamation mark, we're going to read this. N factorial means n times the number 1 less than n, so n minus 1, times the number 1 less than that, times, and then you keep going down until you get to 1. So this is read n factorial. So, for example, let's say you wanted to do 5 factorial. That means 5 times 5 minus 1, which is 4, times 5 minus 2, which is 3, and now you're going down by 1, times 2, times 1, and then you stop there. So what is 5 times 4 times 3 times 2 times 1? I believe it's 120. Yes, it is. So 5 factorial is equal to 120. So notice you can do this on your calculator. You likely have a button to do this on your calculator. Let me just pull up my calculator. So this is the calculator on my computer. So notice right here, n factorial. This is my factorial button. So if I want to do 5 factorial, I can just press 5 factorial, and it gives me the answer 120. So all it did was multiply 5 times 4 times 3 times 2 times 1. So that's nice. Your calculator can do it for you. You should have a calculator. You likely have this button on your calculator. A lot of times it's the second function, so I'd suggest finding it. So straight factorial is fairly easy to do, especially if you have a calculator to do it. Sometimes we want to do operation or more complicated expressions with factorials, and you'll see why when in a couple lessons when we start doing larger counting questions. But we have to do, this is pretty common, where you have a factorial divided by a factorial. So 8 factorial over 6 factorial. So what that means is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 6 times 5 times 4 equals, and now if you want, you could just multiply all these numbers, get an answer on top, divide it by all these numbers multiplied together. And if you have a calculator, that's probably not that big a deal, right? We go 8 factorial, okay, oops, what was that, 40,320 divided by 6 factorial, so 720. So now if we divide that, we get 56. So this is equal to 56. Fairly easy to do. What you're going to notice is it's actually a lot easier if you perform some simple sort of simplifications at this step right here. Notice that we have a 1 on the top and a 1 on the bottom, and we're multiplying everything. So what we can do is we can cancel out a 1. We can cancel out a 2, the 3, the 4, the 5, the 6. So all we're left with is 8 times 7 equals 56. Same answer we had over here, but notice we only had to multiply two numbers, 8 and 7, which you don't even need your calculator to do, instead of doing this large operation. Now you might be saying, you know what, that's complicated. I don't want to remember this. I'm just going to punch it in my calculator. And I'm going to do this. I'm going to give you this example here. 75 factorial over 71 factorial. So what is 75 factorial? I'm not sure if my calculator will. So let's say I do 75 factorial. What is that? Well, that's an exponent with 100 decimal places. Your calculator likely gives you math error because it can't even handle a number that big. So we can't do 75 factorial. It's too big. I'm not sure how big. Most calculators will probably go to about 60. And then it's too many digits and they'll give you a math error. Doesn't mean there's not a number, it just means it's too big for your calculator to handle. But fortunately, we can just do some simplification. Okay, I'm not going to write 69 times, and I'm not going to write any more. Keep going down. So 75 factorial is 75 times 74 times 73, etc. 70. Etc. And we don't need to write them all down. Notice there's a lot of simplification that happens here, right? 71, 71 go. 70, 70, 69, 69. 68, the next one will be 68. And everything here is going to cancel with everything here. So all you're left with is these numbers here. 75 times 74 times 73 times 72. I can't do that in my head, but your calculator should. So I just did it on my calculator and I got this. So instead of getting a math error, I got a nice number. Pretty big, 29 million and change, but doable. Okay, so that is what we need to know about factorial notation. Oh, one more thing. So remember we said it's defined for all natural numbers. That includes 0. So what about 0 factorial? That's a question mark. And that's 0 factorial. Well, no, remember we started, we take this number and then decrease until you get to 1. Well, this number is already less than 1. So a lot of people will say that's 0. The answer to that, it's not going to be 0. By definition, 0 factorial is equal to 1. Okay, so we're going to make 0 factorial equal to 1. You might say, why? I don't get it. That doesn't make sense. And at first it seems like, yeah, maybe that should be 0. You're multiplying by 0. But, I mean, really this doesn't follow our definition. We can't start and go down to 1. So we kind of, you might think we just kind of make it up. And we do. We kind of make it up so that it works for very specific examples. And I think in the next video, when we do permutations, I'll show you why this has to be the case, why we have to define 0 factorial as 1.